Greetings, this is M squared, and today we're going to talk about rational exponents. Just a reminder, a rational number is a number that can be written as a ratio of two integers. So most of the time we see those as fractions or decimals. So this is x, a variable, being raised to a fraction, so a over b. The a in the numerator is our power, the b in the denominator becomes our index, or the root. So another way to write that would be the square root, the bth root raised of x raised to the a power. So again, the denominator is our index. It tells us what kind of root we have, and the top is the power. So if I was going to take 25th to the 1/2 is the same as the square root because the top is the power, so it'd be 25 to the first power. And then the index is 2. So that's a square root. And what is the square root of 25? It's 5. So 25 to the 1/2, same thing as the square root. And the square root of 25 is 5. And so some people know what the third root of 27 is. And some people have to put it in their calculator. So you can either put that in your calculator, the cubed root, or you can actually say 27. You can use your little power. Some calculators have a y to the x key. Some calculators have a little caret key. And you can take that to the 1/3 power. But the cubed root of 27 is 3. And then we'd have to take it to the second power, and so that would be 9. So you could say the cubed root of 27 squared, if you had to rewrite that. But you could just do it in your head if you know what the cubed root of 27 is, and then squared. So over here, 16 to the 4/3 is the same as 16, 3 as the index, and 4 out here. Now there is not a cubed root of 16. And in order, let's see, 16 is 2 times 2 times 2 times 2. There are 3 of them, so we could simplify that because we could split that up into the cubed root of 8 times the cubed root of 2. And the cubed root of 8 is 2, so we have 2 cubed roots of 2, and then we'd have to take all of that to the 4th power. And 2 to the 4th power would be 16, and then we would be left with the cubed root. Maybe I should have done this a little bit differently, but it's the cubed root of 16 again. And so remember that gave us, well, I'll just write it there. And 16, we had it up here, became 2 cubed roots of 2, so we'd end up having times 2 here with a 2 there, because it would be, we'd take that 8 times 2, would bring the 8 out because the cubed root of 8 is 2. So we'd end up with 32 cubed roots of 2 in the simplified form. Alrighty, over here, cubed root of 125 is 5, and then we'd square it. So that would end up being 25. And so those were just single numbers, and now we're going to talk a little bit about variables. When you have a variable raised to a rational root, you really just remember your exponent rules. When you multiply and the bases are the same, we have x and x, we just simply add our exponents. So that would be x to the 2/3 plus 3/4. And of course we need a common denominator, which would be 12, so we multiply by 4 over 4 on the first one, 3 over 3 on the second one to get our common denominator. So we'd be left with 8/12 plus 9/12. And 8 plus 9 is 17, so we end up with x to the 17/12. And the last one, this is a power rule, and our power rule says that if we have some variable or number raised to a power, which is also raised to a power, that we multiply. So we're going to have y to the 1/4 times 2/3. And then just like when we multiply fractions, we can cancel anything in the numerator with the denominator, so 2 goes into 4 2 times. So we're left with y to the 1/6. M squared, signing out.